Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. Integration by substitution with example is the topic of this lecture. An important advice. We must be humble. For definite integrals, we do three things. Number one, we substitute the function, for example, x. Number two, we substitute the integral operator, for example, dx. And number three, we change the limits. This question is from November 21, paper 3-1. Using the substitution, find the exact value of the integral. So number one, we have to substitute the function. We have u, which is already given and always given. We need x as well. So by squaring on both sides, we have x is equal to u square. Number two, we have to find dx. For that, we need to differentiate the given substitution. Make sure you always differentiate the given substitution for dx. 1 upon 2 root x. Therefore, dx. First, do cross multiplication. 2 root x dx. You can substitute root x by u. We need dx. So 2u du is equal to dx. This is the second information which we need during substitution. So keep it in a box. This one as well, the given substitution. We need this as well. Now change the limits. Always use given substitution for the limits. And the given substitution is u is equal to root x. The lower limit is 3. So when x is 3, then u is under root 3. And when x is infinite, then u is infinite. Now we have to substitute. First, copy the integral 3 to infinite 1 upon x plus 1 times root x dx. That's the integral. Now, first we change the limits. When x was 3, then u was under root 3. And when x was infinite, u was also infinite. Copy 1, x. X was u square. This is here. So write u square here plus 1 and root x is u. And dx is 2u du. See, we substituted dx, root x and x, and we change the limits. This is the way to do integration by substitution. Let's integrate this. First, simplify this. Root 3 infinite. Cancel these two u's. So we have 2 upon, we can bring this to outside the integral to make these integral simple. And we have u square plus 1, which we can write as 1 plus u square dx. See, 2 under root 3 infinite 1 square and 1 times u square. This is the structure of the formula tan inverse. I already have done or explained this thing in my previous lecture. See, to integrate functions of these types, we use this formula. First, write reciprocal of this number, 1 upon 1. Then write tan inverse. Then write fraction of these two as an angle of tan inverse u upon 1. Watch my previous lecture on the channel so that you would understand this concept well. So we have 2 tan inverse infinite and then tan inverse root 3. By the way, tan inverse infinite is at pi by 2 and tan inverse root 3 is at pi by 3. So finally we have 3 minus, I think, pi by 6. So pi by 3 is the final answer. This is the way to do questions of integration by substitution. Good luck and Allah Hafiz.